Welcome to the second part of our first lesson. So, here we're going to discuss rotational symmetry. So, for rotational symmetry, if the object looks the same or almost the same after being rotated by a certain angle, then it has rotational symmetry. It's not about flipping the image and getting its mirror, rather, it's about rotating it and still seeing the same design. So, formal definition, it's also known as radial symmetry, and it occurs when a figure object can be rotated about a point called the center of rotation at some angle of rotation less than 360 with little to no change in its appearance. The number of times the figure retains its appearance during a 360-degree turn is what we call the order of rotational symmetry. So basically, we are going to solve for these two aside from knowing whether it has rotational symmetry or not. So let's have some examples. I have already answered a few, so let's go through it. So we have to identify whether the given object has rotational symmetry or not. If yes, we have to find its order of rotational symmetry and its angle of rotation. So first we have this. So if we start here and do a 90-degree turn, we are going to have something like this. So it's not the same as what we originally have. So we don't have the same image yet. So let's try rotating it in another 90 degrees. So a total of 180. So from there, we will get the same image. So we have our first similar image. And then from there, we can rotate it again for 100, another 180 degrees to get the same image. So that means we have two order of rotational symmetry. For the angle of symmetry, it's 180 because that's the first time that we got the same image in our rotation. So there will be times where it's difficult to solve for the angle of symmetry. So what I do is I use this formula instead, 360 divided by the order or the number of times that the image will be the same in a 360 turn. So you will still get 180. So yes, it has rotational symmetry with order of 2, angle of symmetry of 180. Next, so we have here an equilateral triangle. So this is an equilateral triangle. This means that all sides are congruent. So once we rotate it 108, 120 degrees, we will have the same image. So that's order 1, order 2, and then we're going to go back here, right? So that's order 3. So order is 3. Yes, it has reflectional rotational symmetry, and the angle is 360 divided by 3 or 120. Next, for squares, you may also try to answer this. So the answer is yes, it has rotational symmetry. So aside from reflectional, it also has rotational symmetry. The order is 4. Yeah. So the angle is 360 divided by 4. So we get 90 degrees. Next, let's have uh, a scalene trapezoid. So that means no two sides are congruent. So no matter what way we rotate this, it won't get uh, the same result. So this doesn't have rotational symmetry. Next, what do you think? A starfish or, yeah, a sea star. The name is now sea star. So a sea star has rotational symmetry, yes. And the degree is 360 divided by 5. So the order is 5. 360 divided by 5 is 72 degrees. So the angle is 72 degrees. Next, we have a sunflower. A sunflower is a very popular um, flower that we have, especially when we're talking about math in nature. So a sunflower has a rotational symmetry or equal to the number of one of its spirals. So a sunflower will have two sets of spirals. Here, its seeds are arranged in two sets of spirals. One is clockwise, another is counterclockwise in direction. The number of spirals in each direction often corresponds to two consecutive numbers in the Fibonacci sequence. So we have the nth term, and then we have the, if you want to recall what Fibonacci sequence is, just please search. So this was discussed in grade 10 or in 10th grade. So for example, we have these two sets. So it has to be consecutive. So 34 and 55. From here, we know that uh, the sunflower has a rotational symmetry equal to the number of one of its spirals. So we can get 360. Yes, it has rotational symmetry. The order, we can say that it's 34. So the angle is 360 divided by 34. So that's how we get the value. So let's check 360 divided by 34. So we get 10.59 degrees. And then next, for functions, in reflectional symmetry, we have what we call even functions. Now, for rotational symmetry, we have what we call odd functions. So odd functions are functions uh whose symmetric with respect to the origin, as you can see here. So angle of rotation is 180 because once we rotate it 180 degrees, we are going to have the exact same image. So same here in these two. So yeah, this ends our discussion for symmetries in nature and art. So if you have more questions, please let me know. You can message me directly or send a comment. So either way, I hope you have learned something in our first lesson. Thank you so much. Bye.